Hello everyone, I'm Brian McNely from Ball State University. I research professional and technical communication primarily as it occurs in socio-technical networks. And my colleague, Paul Gestwicki, is a computer scientist researching game design and especially computer science education. We've worked on several projects together the last couple of years, mostly exploring the collaborative work of software development and the role that writing plays in that kind of work. Today's presentation is also supported by the work of an interdisciplinary team. Holden Hill and Philip Parli-Horne were undergraduate honors fellows in computer science at the time of the project, and Erika Johnson was a doctoral student of mine in rhetoric and composition. The project that I'm going to discuss today was motivated, first of all, by conceptual interest in the role that various written genres play in the collaborative construction of knowledge among computer science and STEM learners. My colleagues and I recognize that various tools and genres mediate learning development, and following researchers in North American genre theory and cultural historical activity theory, we see writing as a particularly powerful mediational means for learning and development in both organizations and academia. A second motivation was a shared interest in formative assessment, that is the regular real-time interventions into learning activity that might help learners develop stronger deliverables at the stage of summative assessment. Formative assessment, in our view, is a complementary notion to Engestrom's societal interpretation of Vygotsky's zone of proximal development. Here, the distance between the everyday actions of individual learners and new forms of collective activity and participation shrinks, thanks in part to the availability of ubiquitous networked interactions. These motivations and shared interests led us to consider the affordances of using real-time collaborative writing environments in software development. We actually began exploring these themes through Google's Wave application, moving on to Etherpad and finally Google Docs as these tools eventually coalesced over the last couple of years. One of our thoughts was that real-time collaborative writing activities would provide opportunities for modeling behaviors among learners. In other words, seeing collaborators write in real time might lead a learner to reflect upon and then model or even correct what they see. As we really move forward in the prototyping stage of the project that I'll discuss, we developed two key questions. First, we wondered if learning analytics related to collaborative writing might foster greater metacognition among participants. And second, does this analytic data promote both instructor and peer opportunities for real-time interventions as formative assessment? So with these ideas and questions in mind, we developed and then studied a system that generates visualizations of real-time metrics about the contribution and edit histories of collaboratively written documents. The system we developed, which we call Uatu, interoperates with Google Docs to better trace and represent the complexity of collaboratively written documents. We hypothesized that making such data readily visible to all participants would lead to more frequent and robust opportunities for metacognition. In this process, distributed collaborators might gain a better sense of ongoing text development, accompanied by a more thorough understanding of their own contributions to the knowledge and practice of a collaborative team. This project very much leverages the affordances of Google Docs and its suite of publicly available application programming interfaces, of which we primarily use two, the Google Docs GData API and the Visualization API. I'm going to talk next about the technical details of the prototype before moving on to the study we conducted that explored its use. Now, we chose the name Uatu for our prototype application in homage to the Marvel Comics character, the Watcher, a fictional being tasked with watching over the Earth. Uatu is a visualization system that continually watches documents created in Google Docs and shared with a special user account that collects and stores edit and revision data about things like user contributions, changes in document size and time, and a MySQL database running on a local server. As a visualization system, Uatu is comprised of three interrelated modules: Watcher, Viz, and the data table servlet. And these three interrelated modules operate with the Google Docs GData API and the Visualization API. In addition to the back-end architecture, we created a front-end website for users When logged in, Uatu produces basic visualizations of the overall collaborative writing activity for a requested document. These visualizations are generated from document revision histories stored in the local Watcher database. These values aren't truly representative of the entire document, but instead reflect a very close approximation based on frequent polling and 1-minute intervals of the document hosted on Google's servers. In this slide, the top visualization includes document revisions as they occurred over time, denoting who made a particular revision, when the revision was saved, that's noted on the horizontal axis of the graph, and the size of the contribution noted by the vertical axis. Users may adjust the visualization by manipulating the left-hand side of the graph to highlight specific revisions. The bottom visualization in this slide is a horizontal bar chart displaying each user who has contributed a revision and the number of saved revisions they have made to the ongoing document. These visualizations are very simple, but keep in mind that this is a working prototype application for collecting and displaying data about collaborative writing in an array of documents. From the start of the project, we were interested in not only making a learning analytic prototype, but also in studying its effects in use. So I'm going to transition now to a discussion of our research into using learning analytics in collaborative writing environments. Work on the technical development of Uatu culminated in January of 2011 when we began studying its use in a project-based advanced programming class at the sophomore level. We used a systematic qualitative case study methodology conducted with ethnographic methods of field research. Following Dorish, we were interested in determining not only what Uatu can do as a system, but what Uatu does for participants in the course of their everyday work. Consequently, we conducted a series of classroom observations, usability observations followed by stimulated recall interviews, observations of pair and group programming and group presentations, and also semi-structured interviews with participants. These methods improved the reliability of our data since thorough triangulation across data types and instances over 15 weeks led to a deeper understanding of the collaborative behaviors we observed. In total, our fieldwork consisted of 20 different classroom observations with 8 participants, 24 semi-structured and stimulated recall interviews spaced evenly over 15 weeks, 14 observations of student writing and collaboration behaviors conducted outside of the classroom and accompanied by talk aloud protocols. We took over 70 photographs and collected 19 participant-produced written artifacts that were composed in Google Docs, which gave us granular composition and revision history captured by Uatu. Erika Johnson and I did most of the field work and produced over 42,000 words of field notes and analytic memos. So our study generated rich qualitative data about collaborative writing strategies among these 8 novice computer programmers. In this slide, we see a typical scene from our study, a CS student working in Google Docs on a requirements list for a complex 6-week programming project. The document is heavily commented, with formative feedback from both collaborators and the course instructor. Learners found these kinds of interventions to be valuable, and they noted that such commentary helped them think more clearly about the purpose of their prose. In the next 3 slides, I'll detail 3 interrelated themes to emerge from our study, 2 minor themes, and a major theme relevant to learning analytic explorations of collaborative writing. Our first minor theme concerns the collaborative practices of learners. As they worked on a 6-week group project, our participants strongly preferred co-located collaboration, despite access to distributed programming and writing environments. In this sense, the learners' actual practice varied greatly from our expectations as researchers. Many students in the course had never used Google Docs, and we expected that it would ease collaborative writing tasks since students would be able to work asynchronously or even in real time from distributed locations. However, our participants showed an overwhelming preference for both ad hoc and planned collaboration sessions that occurred face-to-face. In this slide, we see one of the advantages of collocation, UML diagrams related to program architecture that acted as an orienting artifact for learners assembled in the same space. In short, participants strongly preferred co-located verbal and gestural collaboration rather than distributed programming and writing collaboration. The primary motivation for this preference appears to be centered on alleviating programming anxiety. For example, one participant noted that pair or group work helped alleviate his programming anxiety since he could receive immediate feedback from peers. Another factor is convenience. Distributed writing is labor-intensive, and participants simply found writing as a group face-to-face to be more efficient. The preference for face-to-face writing collaboration caused us to focus on exactly how participants generated prose in such sessions, and this is our second minor theme. When he was asked who contributed edits and saves to the major written component of the 6-week development project, Terry, one of our research participants, responded, "I think just me and Roy. Roy copied down the stuff on the whiteboard." Roy also logged meeting notes from the oral interactions of team members and face-to-face development sessions. Roy, it turns out, was the designated typist for his 4-person group. When we examined the edit histories of documents in Uatu, we noticed that often only 1 or 2 members of a group made edits and saves to a work that was to be explicitly written collaboratively. We naively assumed that the combination of a version control system and a distributed writing application would lead to more distributed and asynchronous work collaboration, and consequently more group members contributing commits and saves. But our assumption was diametrically opposed to what we observed. Face-to-face collaborations included practices such as verbal interaction, whiteboarding and sketching activities, as we see in this slide, paper prototyping, and ad hoc ideation, for example, via the Google Docs embedded chat feature. In short, many important contributions were ephemeral and thus invisible to Uatu, and there's precedent here in the software documentation literature. Cherubin et al. Found that developer sketches were almost always transient in nature, that they were used mostly to aid conversation rather than constitute official documentation. So because Uatu couldn't capture these dynamic learning and collaboration activities, we were forced to re-examine our perspective on what counts as writing. For example, even though Roy was the designated typist for his group, he certainly didn't contribute a corresponding proportion of the actual writing of the documentation. Examining learning analytic data captured by Uatu would indicate that Roy and Terry, to take one example, overwhelmingly wrote the final learning standards document. But this would not reflect the actual collaborative construction of that document, which was far more complex and nuanced in our observations. For example, other group members often sketched ideas on whiteboards and paper, and they meaningfully contributed to the writing of the document orally in face-to-face sessions. We repeatedly observed collaboration sessions in which all members contributed in meaningful but not necessarily equal ways to the final document. However, because groups preferred face-to-face meetings, gestural, oral, and non-digital contributions that were integral in the collaborative writing of the learning standards document were rendered invisible in the document's edit history. What counts as collaborative writing work in such group sessions, therefore, cannot be accurately measured with the traditional approach to assessment or analytics. So the limitations for visualizing collaborative writing activity with Uatu are obvious. If group members are engaged in complex writing work without writing, their individual contributions will remain invisible to the system. This is actually an encouraging finding despite being contrary to our expectations and hypothesis. We recognize that Uatu's utility is limited for collaborative writing situations in which participants are likely to work in shared space, and where input tasks are delegated to 1 or 2 individuals. Another limitation concerns shorter documents that are collaboratively written by a few, usually under 5 or 6 participants. An individual's sense of text is strong in these scenarios, so Uatu's visualizations actually yield little. The real utility of a system like Uatu, it seems, is in visualizing large, complex documents that are collaboratively written by several distributed participants over an extended period of time, where any individual sense of text is likely to be overwhelmed by the number of contributors, revisions, and saves. A project manager tracking the development of a complex policy document, for example, would benefit greatly from periodic Uatu visualizations. Another clear application of Uatu is in online education, where visualizations of ongoing writing activity may help instructors provide more formative feedback and assessment, helping students learn as they work. Where collaborative writing assignments may be seen as onerous in contemporary online courses, a system such as Uatu could actually facilitate better integration of such assignments. Even in this scenario, though, our study suggests that important ephemeral forms of ideation and development would still contribute to final deliverables. These are forms of thinking and doing that remain difficult to capture with current learning analytics systems. I want to thank everyone for their time, and I'm happy to take questions or engage discussion at this time.
Hi, Brian.
Hi.
Was Uatu able to capture collaborative efforts that happened in parallel versus being in synchronous effort?
You mean if there were three people working on a document?
If efforts were happening at the same time in a collaborative effort versus in order?
Yes. The API logs commits and saves, consecutively as if they happen in order, even though what we're capturing is essentially real time. So yes, it gives us data on 3 or more contributors all working at the same time.
Any other questions for this very large head? You're a very large head for us here.
I'll back up.
Larger than life. Anyone else? No? Okay, well, thank you very much for being here and sending your recorded speak ahead of time.
Thank you.
Thank you.
Thank you, Brian. So yeah,
Thank you.
I'll talk to you later. Cheers.